Good morning, DEF CON. Yeah. How many of you guys went to the Demon Saw party last night? Anybody? Yeah? One guy? The fact that you're here means that you didn't do it quite right. I was expecting no hands. Did you see McAfee last night? Yeah? I'm sorry. All right, so one quick announcement. We're going to get started pretty shortly. About 2 minutes, we're going to get this fine gentleman going. When you leave the room, please use the back doors, not either side. They're pretty well marked, but back doors. We had some issues yesterday. The other announcement is yesterday we were told by hotel staff that there was some unusual traffic on their point of sale network. They have paid for a very, very high-class monitoring solution just for DEF CON, and we have a very, very superb, I know it's DEF CON, but we have a very, very good standing with all of the hotels and conference centers in the area for not messing with them too hard. POS system, not cool. Please do not mess conference center or hotel's network at all, please. If you really feel like flexing some particular gray or black hat muscles, DEF CON network is there for a reason. Bring it on. All right. So we are right on time. That is amazing. So without further ado, Benjamin Holland, our first speaker of the day. Let's get a round of applause. Yes. All right.
Thank you. Thank you, everyone, for coming today. So my name is Ben, and today we're going to talk about a way to develop managed code rootkits for the Java runtime environment. So just a little background who I am. I guess I would describe myself as a student. I've been a student for a really long time, and probably will be for a little longer. I've worked a few places, and I come from Iowa State University. I see a few other people from Iowa State here, so yeah, represent. All right. Okay, so a little background. First, I just kind of want to show you a little taste of what's to come. So here's our simple Hello World program. Everyone's probably written this program before, right? So let's go ahead and run it on our victim machine and see what happens. So let's go ahead. Okay, so we've got our this is just a Windows 7 latest Java update as of Java 8 as of like a week ago. We go ahead and run Hello World. It just prints Hello World. But we've got a session on this machine. We got Meterpreter running, and we're going to load up this custom post module. Whoa. Okay, and we're going to go ahead and run this custom post module. I've got a dropper here. We'll explain what that is here. We're going to go ahead and manipulate the runtime a little bit. And then go back over to the victim machine and see what happens. So now when we run Hello World, it prints backwards, right? So we have the ability to manipulate the runtime. And what are we going to do with that? Well, we can talk about that today. Okay. Okay, so first of all, we should probably understand a little something about what the runtime looks like, at least from a high level. So we take Java code, just plain Java source files. We feed that into the compiler. We spit out class files. We could run those. Or if we have a bunch of class files, we just zip them up. And because we're Java, we call it a jar. So that's just a jar. It's just a zip file. We take that jar file and we run it on our host operating system. So that's Windows, Mac, Linux. And it seems to run the same on each one, right? So it's cross-platform. That's really nice. But how do we do that, right? If you write a C program, you might have to change things a little bit. But with Java, at least it's standard. So the way we do this is we create a custom virtual machine for each host operating system, and that interprets the standard Java bytecode and then runs it on the host operating system. So let's take a look inside those. We have the virtual machine, and then we have the standard library, right? We have the definition of what's an object, what's a linked list, all the different primitives inside this runtime jar. And what we're going to do today is actually just mess with that runtime jar, right? And because this runtime jar is actually just Java bytecode itself, at least for the most part, that also has this nice property of being cross-platform, right? So we can write one exploit and then run it everywhere. Okay, so there's a few advantages. First of all, I just want to make it clear that this is a post-exploitation activity. So you've already gained permission on the box. You can write to usually these kind of protected directories. So program files on Windows is where they store the Java runtime. Of course, if you didn't store it in a good place, someone could just manipulate it without having administrator privileges. But the important part is that we're not manipulating the program itself, we're manipulating the runtime. So actually, we can affect every program that's running. So that Hello World program, we didn't touch that program at all. We touched the runtime, and then the Hello World program behaved differently because we modified the runtime. So, there's some nice benefits of this. Typically, we audit the application code. We don't audit the runtime. Someone might overlook this. And we have a lot of contextual information about the application, right? So if we wanted to do something like grab the password field, we don't have to write an entire keylogger. We could just keylog maybe just password fields of applications. So we have some more contextual information at the application level. And of course, since we're manipulating the runtime and we're doing it, at an object-oriented language, these are full-featured libraries, so we can write object-oriented rootkits. We can use the standard library. We have lots of access to kind of some low-level things that you might not think are in there, so we can mess with key events, networking, all sorts of things. Okay, so there's been some pioneering work. I'm not the first to do this, and I'm not really expanding on kind of the main technique. I just want to expand on a new way to do this. And so Erez Metula gave me this book, and he's done a lot of work on this already. So if you're curious about, kind of all the things you can do, you can check out his book. It's called Managed Code Rootkits. And he also released a tool called ReFrameworker. It worked on .NET runtimes. I was able to kind of specify XML tasks of how to manipulate the runtime. And this uses an assembler and disassembler pair to make the modifications and has some deployment scripts. So really kind of laid the framework, the groundwork for how we're going to do these. But when I started thinking about this, I wanted to do this for Java because I'm kind of a Java nut, as some of my friends know. And the previous tool was for .NET, so I thought, well, I have to extend this, but I have an opportunity to think about, how am I going to modify the runtime? So there's a couple different ways you could approach this problem. We have bytecode. We could just try to manipulate the bytecode right away. But this is pretty difficult, right? It would work, but say you change a variable name or a method name, well, that has lots of references in the code. So we have to kind of change all those little references, and the butterfly effect gets kind of a pain to manipulate. Also, most people don't speak raw Java bytecode code, so that's just kind of a pain. Ideally, we could just decompile this, get the source, edit the source, recompile it, and we're done. But if anyone's decompiled apps before, if you're lucky that it even compiles, it's probably not even right to start with. So decompiling things is definitely a hard problem, very hard, and we're not going to have perfect decompilers. So people come up with things that are kind of in between. So we have these intermediate representations. They're used a lot in compiler optimizations. For Java, you can think about Smalley or Soot's Jimple, any of those representations if you played with those. But this is nice because we can decompile it to this kind of halfway point. It's not quite source code, but it is text. It is a source code, but it's not Java source. And we can edit that, and then we can recompile it. And we come to this halfway point because we can guarantee that we can go back and forth between decompiled and compiled output. Editing the bytecode works. It's a huge pain. We can't really rely on decompiled source, although we'd really like to work with that. And then working with intermediate representations was kind of my first approach. And it has been kind of proven. People have done this. But it's still tricky. We learn to write code at the normal source level. We don't write code at an intermediate level. It's just kind of it's just something we can write tools for, but but it's still tricky. So I thought I really, really want to just be able to, lower the barrier to entry so that if you know how to write basic Java programs, then you can write a managed code rootkit too. So that's kind of the new goals of the framework, right? I want to support the Java runtime environment, and I want this just really low knowledge prerequisite. So just quick, show of hands, like who has ever written just a basic Java program? Okay, yeah, so you guys can all write a managed code rootkit now. So that's fun and also terrifying. All right, so the other thing is we want kind of this natural development environment. If you've written a Java program, you've probably used Eclipse, right? You at least, whether or not you like it, maybe you like another IDE, but it's familiar, right? You know how to debug your program. You know how to easily deploy your program. And again, if we can write something from high level in source, we can strive towards this portability, and we don't have to worry about kind of low level details in the runtime. So I want to, oh yeah, I had this slide. Okay, so we want to write rootkits in Java source. This is the tool itself. I called it JReFrameworker, and that's kind of a ripoff of Erez Metula's ReFrameworker, just because kind of a common pattern is just to add J in front of a Java project. But then I noticed, oh, JRE, that's nice. So I kept it and I got it kind of attached to the name. So it's an Eclipse plugin, so you can work right inside Eclipse. We have an ability to export a way to drop the payload on the victim machine. So that's all kind of abstracted away from you. It's open source, it's free, so you can play with it, hack on it, and have fun with it. So there's been some early feedback on Twitter. So some guy said, just what the internet is in dire need of, a well-engineered malware development toolset. I think he was being sarcastic, but I'm going to take that as a compliment because I like the idea of a well-engineered tool from me. So I want to revisit that Hello World program. So this is all the code that you have to write. And the idea is what we'll do is we'll extend, since it's object-oriented, we'll extend the object that we want to manipulate. And for now, just assume that you can extend any object. So here I'm extending the print stream. Let's see, can I run the mouse? Yeah, okay, so I'm extending the print stream. And we have these little annotations that define how we want to manipulate the runtime. And these are basically just notes to the tool. They won't end up in the final source. So we're going to say we want to merge these two types. So we're creating a new class called backwards print stream. We're extending the print stream, and we're going to merge this new behavior in. And what we're going to do is actually override the println method to just create a new string, reverse it, and then print that string. Okay, and so we have quite a few different annotations. Not too many, I guess, actually. There's two main types. There's define and merge. So a define type basically inserts or replaces the old behavior. Because sometimes you just want to completely blow it away and replace it with something new. But sometimes you want to preserve that old behavior and then maybe just hook into it or add a subtle difference to it, but then behave like normal in other cases. So that's what the merge type is. And you can put these on each thing. You put it on a class, you can put it on a method, you can put it on a field. And then we'll get to why we need these later, but we can also control the qualifiers on things. So if a class is final and you can't extend it, well, you can basically just say, nope, no, it's not, and then extend it. Right? Okay, so I'm going to do just a quick demo here of how to use the tool so that if you want to play with it, that you can. Okay, so let's go over here. So I have a little bit of test code here. It creates a new file called secret file. It writes to that file, just writes the word blah to it, and then it checks to see if that file exists or not. And then just to clean it up, we delete it. So if I go ahead and run this, of course it works. I just ran it with the normal runtime, nothing's changed. But what we can do is actually override this. So I'm going to extend the file class. And okay, so we've extended. We can use Eclipse to kind of help us out here. We need a constructor. Okay, no problem. Eclipse, you can generate that for us. I want to merge this. Let's see, merge type. Okay, I want to merge this into the file class. And what I want to do is override the exist method so that if the file name is secret file, I'll just tell you it doesn't exist. Even though it does, we can still write to it. We can still read from it. Okay, so I'm going to use another annotation. This is just a basic Java annotation. It checks to make sure that the method we say we're overriding is actually a method that we're going to override. And this is the exists method, so public boolean exists. And we have to return something, so I'm just going to return false for now. Okay. And so let's check to see if the file name is a secret file. So let's see. Let's first say if it's a file and not a directory, for instance, and the name is secret file, then we'll just say nope, no, it doesn't exist. Trust me. Otherwise, let's just use the default behavior, right? So the default behavior is the method that we're going to replace. So I'm just going to return the original method. So I'm going to use the super call for that. So this will later get rewritten so that all of this works. Okay. And then we also have to say I want to merge this method into the, there we go. Okay. Now there's an Eclipse builder built into it. So yeah, I guess I should first say you'll create a new project. So you can do new, other, and then there's a JReFrameworker project. There's support for other things too. And that'll set up the class path, everything like that. So as you're developing here, you're not actually, you'll be manipulating your runtime, but you're not going to actually affect it. We're just going to do it locally, and then we'll just kind of hot swap it at runtime. So I'm going to go ahead and build this project here. Don't have a incremental builder yet, so you have to do a build clean, but things are coming. It's a work in progress. Okay, so we're building down here the progress. We'll hope it works here. Pray to the demo gods. Okay, so we run it with the normal runtime. It says true, but now we're going to run it with our manipulated runtime, and it says false. So it worked. Okay, but we know that that file exists because we wrote to it, right? So weird. Okay. Now let's take a look at what happened under the hood. So I'm going to load up just a JD GUI, just an easy Java decompiler here. And let's decompile the modified runtime just to see what's in there. So I'm going to go to Java file IO, go down to file, and I will search for, let's search for the exists method. Exists. Nope. Okay. So here's the original method, and all we did was rename it so that we can call it later. And then if we can find the other exists. Okay, so here's our new one. It's the code that we just wrote. And the recall to super now just calls our other method, which we made private so that nobody can see it anymore. Okay, so I'm going to quit that. We'll go back to the slides here. So really easy, right? We can test this, we can run it. Oh, I guess I could say if we want to actually debug this in our test code, we could go back over here. Instead of invoking the file, we could just try our normal one. So if we want to set breakpoints, stuff like that, we can just debug it locally without actually manipulating the runtime. And then once we're confident with it, we just change the target, manipulate the runtime, and everything will work fine. Okay. So now we have a little bit of fun, right? We have a framework. We can just start manipulating things. So this is just kind of a fun one. What I'm doing is overriding the print stream object yet again. This time we define a new field. It's a integer called Beetlejuice. And every time the println method is called, we look at the stack trace. So we're looking to see who called us, right? And if there was a method named Beetlejuice, we increment that counter. And if the counter is 3, then we call this call. And we'll see what that call does in a minute. So we have to now think about what would trigger this code, right? So we have a method named Beetlejuice, and we're going to invoke it 3 times. And we're going inside Beetlejuice, there's a call to println, so we'll trigger that code. And it'll go Beetlejuice, Beetlejuice, Beetlejuice. If we run this normally, it's not very interesting because, actually let me skip forward just a little bit since we already explained all that. Okay, if we run this normally, it's not very interesting. It just prints the hash code of the Tim Burton object. I'm a fan of Beetlejuice. Anyway, but if we run this with our modified framework, yes, so someone has ported all of Doom to pure Java, and just as a test of how much complexity we can shove into the runtime, why not just shove the whole video game in there? So it about doubles the size of your runtime, but that's okay. But what's fun is, our client can have kind of fun little triggers, of what we want it to, of how we want to trigger it. So here's another one. Okay, I reordered my examples here. Okay, so this one is just kind of to show off the other things. So normally, if you call the string replace method, it doesn't modify the variable that it's operating on. So the receiver variable, it doesn't modify that. So in this case, demand replace sacrifice with puppy, then it wouldn't do anything. So the normal behavior was, it would just say Satan demands a puppy, or sorry, it demands a sacrifice. But if we make strings mutable and we make this actually modify the behavior, then string replace works like how some people think string replace works, and actually prints Satan demands a puppy. So this one's tricky because a string is sometimes treated like a primitive object, so you shouldn't have to extend the string class. So they make it a final class, and you want to be able to treat it as mutable so you can make those assumptions when you're programming. So they actually make the value of the string a private field and a final field itself, so that you can't change it. But of course, we control the runtime, so we can easily update that. We just say, nope, string's not final. Nope, the value field is not final. And hey, well, let's make it protected so that we can actually manipulate it and play with it. Okay, so we can do all sorts of fun things. So I just kind of went crazy. There's a whole bunch of modules that I had to cut from this talk just for time reasons. But I'll release them all on the GitHub repo right after this. So this one it takes, whenever someone loads an image, like a JPEG or something, in a Java GUI, they have to access the raw data of the image. So this just basically adds a hook that says, before you access that image, why don't you pixelate it for us? And why would we want to do that? Well, for the glory of Satan, of course. And of course, we control the pixelation, so we can just make this as pixelated as we want. Here's another fun one I really like. So this came from a talk and was partially the inspiration for this talk. I was trying to say, what's the difference between, how do we detect malware if we don't have a definition of malware? So in this case, I wrote a spell checker. And the spell checker was just a normal spell checker. And then I went through and I inverted all the logic, right? So what do we have now? Something that creates typos, right? It just creates kind of realistic typos, follows the same sort of rules. They're just all backwards. And then what we can do is we can hook this into a key event so that the faster you type, the more typos we create. And then as you slow down, we start to behave again, right? So it's just kind of killing your productivity, and it's really annoying. In fact, the first time I tested this, I didn't realize that Windows has two different runtimes, a 64-bit and a 32-bit. And I was trying this, and I just couldn't get it to work. And I was running on the command line. And then I went back to Eclipse, and I realized it's working. It's just working on the wrong runtime. Okay, so I have a demo of this. So you can tweak the parameters. This one's actually better to run in some sort of test harness, so you know what typo is mine and which one's not, because I'm trying to type as fast as I can. So when it turns red, it's creating typos, and then as I slow down, it starts to behave again, and everything's fine. So you can kind of play with with the sliding average to see how devious you want to be. There's lots of parameters there. So that one's kind of fun. Oops. Okay, back to slides. Okay. So now, I really liked this idea. So people will think about, we have a CVE, and we want to create antivirus to detect the CVE, or to detect the malware, right? But what is malware? So I like this CVE. I've gone through this a few times now, and I really recommend if anyone hasn't, just pick a CVE and try to just understand as much about that CVE as you can, and go through, try to recreate it yourself. It's a lot of fun, and you learn a lot of things. So this one was really popular. There was a Metasploit module. It worked on basically every platform. The original bug was in Oracle itself, so people like Apple copied it into their runtimes, and it was exploited in the wild, and people were just having all sorts of fun with this. And I think that's probably one of the reasons Chrome doesn't ever let you run an applet anymore. But so we have an existing exploit for this, and I wanted, I did an experiment a little while ago, about 2 years ago, just to see, how could I, just change this a little bit just to get it past AV. So we all know AV is bad, right? It's hard to write good AV. I've tried. But anyway, so let's just see, what are all the different antiviruses doing? So I created, I took the original proof of concept that was reverse engineered from the malware in the wild. I uploaded, so this is 2014. I uploaded it to VirusTotal, and 30 out of 55 people detected this, and this is 2 years after, after the exploit was out. So, not great. But then let's just start refactoring it a little bit. So start changing the class names, the variable names, and we lose 2 people right off the bat, right? We lose 2 AV right off the bat. We start just obfuscating strings. So if we have a string, we just break it up and concatenate it. So now the AV has to kind of reassemble that or do some symbolic execution, something like that. We can change the control flow, so we can start merging methods, splitting things into multiple methods, add dummy if branches, stuff like that. And that one didn't seem to do too much, so nobody was really looking too hard at control flow. But then what we can do is start looking at, okay, well, what are the key APIs that people are, that people are keying off of, and let's just use reflection or another layer of indirection to call those, so that so we throw them off, and we lose a bunch of people right away. But of course, we can do way better. We could just put the whole class into a string, XOR it with just a simple key, just a 1-byte key, and then load it with a class loader at runtime and run it. And so nobody gets that. Okay, so not a big deal. If you guys want to play with this yourself, all the source there for all the different versions is online. So I did this 2 years ago, which was 2 years after the exploit came out. I decided, let's just do it again one more time. So I run it again, and well, we got a new antivirus in the game. And 6 more people found it, but there's still, like 20 people out there that I can't find this. Changing the class names, so we actually got a little bit better, right? Things like changing the class names, nobody's keying off of those sort of things anymore. Obfuscating strings still works a little bit. The reflective invocation still helps, but still, nobody can get the XORing thing. And that's a hard problem. I don't blame them. But it's just that easy, right? Anyway, so why don't, I was kind of bummed out. This bug doesn't exist anymore. It was used lots in Java 1.7. They fixed it, but hey, we control the runtime, so let's just put it back in, right? And so I call this the reverse bug patch. Yeah, so I'd love to automate this, and so someday. Anyway, so the fix was really, really easy. I started downloading all the versions of Java, and then started doing differencing on them. And you see the fix is they just add 2 calls in the class finder object to check package access. And this was because basically someone was able to use reflection to avoid a security check by kind of tricking the runtime into thinking that the call was coming from a different origin. So we just add this check and we're fixed. There's another check that was added to method finder. This CVE actually consisted of 2 different vulnerabilities that were used together. So we have 2 separate bug patches. And then they removed a field. I think this was just a case of refactoring later. They removed another method that we were using for the exploit. So no big deal. We'll just put them back in for you. Of course, if you want to upload malware to a target, yeah, that's fine. But why not just upload a vulnerability and then come back and exploit it again later, right? Because if we know we can't detect the vulnerability, then we left ourselves kind of a nice backdoor. And we have lots of examples of great vulnerabilities that nobody's looking for. So of course, I mean, this is expected. You upload this to VirusTotal, this modified runtime, and nobody's going to detect this. So we're not looking for the vulnerabilities. We're looking for the exploits. Okay, so maybe some good uses for this. So this was a master's project that I helped a student with at Iowa State. So he was looking at things like, can I take old SCADA HMI applications and secure them somehow? And so if we have a SCADA HMI application, a lot of these happen to be Java applets, which would communicate with some backend server. So he started creating things like a kind of a smart, intelligent firewall, application level firewall, that would wrap the server. But then we need a way to, if we want to do something like support two-factor authentication, we need a way to give some sort of feedback to the application so that the application can prompt the user for their token and then feed that back to the firewall. And we can also do some things like add some profiling logic, so we can do something kind of like active defense. So we can, of course those could be disabled, but it's just nice to be able to add another layer of authentication. So in this case, we have this SCADA application. We don't have the source code to it. But that's not too hard because we can just find the object, maybe that controls this alarms list and say we want to add additional security around this alarms list. We can add, the two-factor authentication, which lets you through the firewall just to access the alarms list data. So in this case, it's just a real simple couple lines of code with some JSON that passes the result back and forth. But we can add this prompt and secure this application. So I added support to JReFrameworker to modify applications as well. There's some really early basic support for Android stuff. That one's really early because you have to go through some additional tool chains. But let's talk a little bit about the mitigation. So how are we going to, I'm trying to make this project, I'm making things a little bit worse by making it easy for everyone to write these. So let's talk about the mitigations. Okay, so does anybody see anything wrong with this picture? This is our file example before. Okay, so if we look at the line numbers, these are added by the compiler for things like decompilers or debugging, adding to the stack trace, what line you crashed on. But you can see in my framework, I wasn't too worried about being super stealthy. I just wanted it to work. But when I inserted the new method, I didn't go back and recalculate the line numbers. So you can see at the end, we're at the end of the file, and it's like line 2000 something. And now we go line to 18, 19, 21, and then we're back to like 2000 something again, right? So there's lots of fingerprints that the runtime's going to get added. If you're not manipulating byte at the byte level, some tool is going to add some fingerprints as a result of its manipulations. So we can start to look for these things. So the easiest way is probably, have a baseline of all the files on your system and know when they should be changing. Did you run Java update? No? Then why'd the hash change, right? But of course we can, we've rooted the box, so it's kind of game over for you anyway, because maybe I'll just backdoor the Java updater, and after you update Java, I'll remanipulate things again, right? So we can have a lot of fun with this. Another kind of fun indicator was the Java runtime is about 50 megabytes, but after I manipulate it, it's about 25 megabytes, which is weird, but it's just because I'm using a different compression ratio. So I could try to match the compression ratio of the original library, but it doesn't matter. The jar file is a zip file, so it still works, but these are some of the indicators that you can look for. When you rename the methods to kind of preserve the old behavior, I'm just renaming methods, so you could just look for that easy prefix. I have a preferences menu if you want to change that prefix and not use this default JRef underscore. That's up to you, but there's still going to be kind of a pattern. You could count the number of methods and know the number of methods in each class file and expect, it's going to kind of grow at this rate with each update. And if you see a huge spike, then you should know why, right? Okay, and of course we can use all sorts of code complexity metrics, but yeah, we'll have fun with that later. So the biggest thing is being aware of it, right? So if you're a forensic investigator and things are behaving weirdly, you might want to look at something like this. And this is generally an awareness project. Erez talked about this about 6 years ago, and I was really surprised that nobody else had really done anything with this since. So hopefully by lowering the barrier to entry, people can play with this more and will be more aware of it as a community. So my biggest point was, if I could do this as an evening hobby, anybody could be doing this, right? And if we're not thinking about it, that's a problem. Okay, so I have some Q&A, and if I have tons of time left, I have more modules I can go through. But I'm happy to take questions. I just have this kind of closing poem by Robert Frost, which basically is my way of saying there's a lot of work left to do on this. I'd like to support quite a few more things. I'd like to look at other languages. So the Java virtual machine itself, I'll come back to this, but the Java virtual machine itself isn't just for Java. It supports lots of languages. In fact, there's, Invoke Dynamic was kind of originally added to support things like Jython with all their kind of dispatching. But if we can manipulate the Java runtime itself, we can start to kind of branch out and start to consider other things. So things like JRuby will just call into the Java runtime jars to kind of reuse those languages so you can mix and match things. So if you have a JRuby website, you can start to manipulate it that way. And so I just want to say that it's not just about Java. There's lots of managed languages out there, and they're all going to have the same sort of issue. Okay, so the source code's out there. If you're interested, please play with it. Make feature requests. I'm happy to support it, and I'd like to keep working on this. So thank you very, very much for coming. I'm happy to take any questions you have. Thank you. Yeah, that's fine.
Hello.
Hi.
So if you're modifying SCADA devices, perhaps to improve the security by playing with their Java runtime libraries, then the opposite question comes up. How in the world do you discover whether somebody else did it?
Yeah. So you're asking whether or not. So if you modify the application, how do we know if it was modified for good reasons or for bad reasons?
Well, just arguing that the #1 rule of security is that it's easier for the good guy than the bad guy?
Yeah. So I think this would be something you would want to do. I mean, you would do this in-house, right? You would have a specific need for this application that you don't have the source code to this for whatever reason, and you want to add this feature or add this new ability. This is a way that you could, modify that binary and then sign it and keep track of that hash in your deployment system. So I'm not necessarily advocating that you should do this. It's just that you could use it for this purpose.
Okay, so I'd have to have like a standardized deployment.
Yeah, I mean, if you're deploying this, this already, you should have some system in place for how you're going to deploy it. Of course, if the application's signed, you're going to have to re-sign it with your own application key and keep track of that, because you're going to violate the hashes in the manifest by doing this.
Thank you.
Have you tried to circumvent the requirement that cryptographic providers be signed? So you put in your own key generator class in the JRE. Have you tried to do anything like that?
No, I haven't played with that too much. I basically just got it working, then played with a few modules. Are you talking about the class loader stuff or applet security? Where are you talking about with the key
okay,
signing?
if you're creating a security provider that provides key generator,
yep,
and you want to use it, that has to be signed by Sun Oracle.
Right.
And so you have that jar in the JReLib.ext directory, and you have it in java.security.
Yeah. No, I haven't tried to bypass the key signing on the manifest, anything like that. What I did was, if it was signed, basically I just blow away the manifest, re-sign it with my own key.
Yeah. Now you're modifying the JRE and not the application jar.
Yeah, the
correct?
JRE is actually not signed.
Right.
Yeah.
So you could patch that, and if there's key generator and key generator spy, which the security provider provides.
Yeah, that would be interesting. I haven't tried that. Yeah, that's a good idea.
Hopefully not.
provide a way to modify the static part of the code?
To modify the stack, so underneath it's using ASM. So if there's things like, say you add a parameter to a method, you've changed the stack size on the call. So in that case, it recomputes the stack when it makes the modifications. So that part is handled by the ASM library. It's a pretty robust library. It's used in a lot of things.
I mean the static method.
Sorry, can you ask it again?
The static method of the class. You cannot extend, right?
So, if you can't extend it because it's marked final, yeah. So in that case, there's an annotation. I used to just call it, sorry, losing my voice. I used to just call it not final, but in this case, it's just define finality, true or false. So in that case, like string was marked final, you can't extend the class, but now you first mark it as not final, and then compile it once. Now you can compile it against it again and extend it, add your feature, and then compile it one more time. So you can have multiple passes if you want.
It's not final. It's only static. So it's.
Oh yeah, you can change whether or not something's static. No, actually no, you can't. Because if it's not static, you've changed quite a few things. If you want it to not be static, I would either just declare a member variable that you're going to use for that. If you make something not static, you're going to impact quite a few things. I'm actually not sure what the use case for that would be. But if you have one, I can look into making that. Yeah.
It's like certain initialization, sometimes in the static.
Yeah. So right now I don't handle the static initializers. So you can. It just gets kind of tricky when you start playing with the super calls. It's something. There's actually this white paper right here talks about one way that you can do that if you want to merge, say, two constructors or merge the static initializers of two different classes. That's something that has been done before. I didn't need it for any of the examples that I did today.
Okay, thank you.
Yep. Okay, well, thank you guys for coming. I appreciate it.